Have you ever stopped to think about how the code on your screen actually makes a choice? You know, how a game decides to play a sound, or how a streaming service recommends one movie over another? Well, it's not magic. It's actually a carefully planned adventure. And today, we're going to map out the exact journey that every program takes.
So let's get right to it. At the heart of everything is one simple question. How does a piece of code, it's just text in a file, right? How does it actually make a decision? How does it know to choose one path instead of another? That is exactly what we are going to unpack. The secret to all of this lies in a concept called flow of control. Now, think of this as the rulebook for our code's adventure. It dictates the exact path the computer is going to follow. It's how we tell the story, one instruction at a time.
Okay, so every adventure has to start somewhere, right? It's got a default path. And in programming, we call this sequential flow. It's the most basic, most fundamental route our code can possibly take. So by default, Python reads your code just like you would read a book. From the top to the bottom, one line after another, no skipping around. Statement 1 runs, then statement 2 runs, then statement 3. It's simple, it's predictable, and it's the foundation for literally everything else we're going to talk about. But let's be honest, a straight path isn't much of an adventure, is it? The real fun, the real power, begins when we introduce choices, forks in the road. And in programming, we create these paths using what are called conditional statements. The simplest choice you can make is the if statement. It just asks a simple yes or no question. If the answer is true, the code gets the green light to take this special little detour. But if the answer is false, it just ignores that path completely and keeps on going straight. So an if statement is kind of like a take it or leave it choice. But what if you need a clear this or that decision? Well, that's where if-else comes in. It gives you two distinct paths. If the condition is true, you go down path A. But if it's false, you have to go down path B. There's no other option. It's one or the other. And what about when life gives you way more than just two options? For that, we've got the if, elif, else structure. Just think of it like a chain of decisions, or a series of checkpoints. For instance, let's say we've got a score of 85, and we need to assign a letter grade. So the program first checks, is the score 90 or higher? Well, in our case, 85 is not greater than or equal to 90, so that's a false. The grade A path gets completely ignored, and the program just moves on to the next checkpoint. The very next check is elif, which just means else if. It asks, is the score 80 or higher? Well, 85 is greater than 80, so bingo, that's a true. The program immediately jumps onto the grade B path and runs that code. The adventure for this little section is decided. And this is the key to why it's so powerful. The moment a condition in that chain is found to be true, the program takes that path and completely ignores all the other checkpoints that come after it. It's super efficient. It doesn't waste any time checking things it doesn't need to once it has found its answer. But hold on, how does Python know which lines of code belong to the grade B path? In a lot of other languages, you might use curly brackets or something, but in Python, the answer is so simple and clean, it's indentation. That white space at the start of the line isn't just for making things look pretty, it's the actual rule that tells Python which instructions belong to which path in our adventure. So, we've learned how to choose a path. But what if our adventure needs us to do the same task over and over and over again? Well, for that, we need to learn how to run in circles, but, productively. We do that using loops. Python gives us two main kinds of loops. First, there's the for loop. This is like being told to run 5 laps around a track. You know exactly when you're going to start and exactly when you're going to finish. Then there's the while loop. This is more like being told to search a forest until you find a hidden key. The repetition just keeps going as long as a certain condition is met. Now, for those run 5 lap scenarios, the for loop needs a way to count, and that's where its best friend, the range function, comes in. It's basically just a simple number generator that tells the loop exactly how many times it needs to repeat itself. It's counting the laps for us. The while loop, on the other hand, is a little simpler in theory. It just keeps running as long as its condition stays true. But, and this is a huge but, this comes with a really important warning. Something inside that loop has to eventually make the condition false. If it doesn't, the code gets stuck running forever, what we call an infinite loop. Okay, now that we know the rules of loops, let's talk about how to break them. Because sometimes in your adventure, you need a secret passage, maybe an escape hatch. And for that, we have what are called jump statements.
There are two main jump statements you need to know. First is break. Think of this as the big red emergency exit button. It stops the entire loop right then and there, no questions asked. Then you have continue. This is more like a skip button. It just ends the current lap early and jumps right back to the start of the next one.
Let's see break in action. Imagine we're counting from 1 to 10, but we have a condition that says to break when the number is 5. Well, the loop starts counting 1, 2, 3, 4. But the moment the number becomes 5, bam, the loop stops dead in its tracks. It never even prints the 5. The adventure in that loop is over. Now look what happens with continue. Using a similar idea, if we tell the code to continue when the number is 3, the loop doesn't stop at all. It just skips printing the 3 and jumps straight to the next lap, which is 4. And that's the key difference, right? One is a hard stop, the other is just a little skip.
Wow, okay. We've learned about straight paths, we've learned about choices, and we've learned about repetition. Now, let's see how all these pieces can come together to solve a real programmer's puzzle, sorting 3 numbers. All right, let's trace the logic here. Our numbers are 10, 30, and 20. The program's first question is 10 greater than 30? Nope, that's false, so it just moves on. Second question, is 10 greater than 20? Still false, so it moves to the final check. Is 30 greater than 20? Yes, that's true, and that triggers an action. The program swaps B and C, and just like that, with a series of simple choices, our numbers are perfectly sorted. 10, 20, 30. The puzzle is solved. And really, there you have it. Sequential, conditional, and iterative flow. These are not just some technical terms. They are the fundamental tools you use to control the story your code tells. This is your adventure toolkit. So you now understand how programs make decisions, how they follow these complex journeys. The question is no longer about how they do it. The question is, now that you have the rules in your hands, what adventure are you going to build? What story will you code next?